Welcome to this video tutorial. Today I will discuss M.F equation of single phase transformer. In the screen you can see a single phase transformer where the input voltage is 230 volt, output is 6 volt, that is step down transformer. After watching this video, you will be able to answer the questions like derive the expression for the induced EMF of a transformer, explain briefly the action of a transformer, and show that the voltage ratio of the primary and secondary winding is the same as their turn ratio. Before the derivation of EMF equation, I will discuss briefly what is transformer and how a transformer works. Here I am drawing a simple schematics of a transformer which consists of a primary and secondary windings put on a magnetic core. Transformer cores are made from thin sheet of laminations of high grade silicon steel, and a magnetic core is used to confine flux to a definite path. The magnetic circuit consists of two vertical limbs called legs and two horizontal sections called yokes. The primary winding is connected to a single phase AC source, that is V1. When it is connected to the alternating source, I0 current flows in it. This alternating current produces an alternating flux, and this flux I have written as phi is equal to phi m sin omega t. It's alternating in nature, and this alternating flux links the primary winding as well as the secondary winding. According to Faraday's law of electromagnetic induction, the changing magnetic flux induces EMF in the primary winding as E1 and in secondary winding as E2. So this way the power is transferred from primary winding to secondary winding. So transformer is an electrical machine that transfers energy from one circuit to another circuit without the change of frequency. So if the primary source, those frequencies F, then secondary frequency is also F. Now we will derive the EMF equation of transformer, where we will see that the alternating flux phi is equal to phi m sin omega t is used. And we know the flux in alternating in nature, so let the flux at any instant phi is represented as phi m sin omega t. So sinusoidal flux is producing. As the flux linking the secondary winding, so this instantaneous EMF is induced in a coil, say n turns. I am not telling that primary winding or secondary winding, any coil, one changing flux is there, EMF is induced. Here we have taken a n turn coil. So according to Faraday's laws, this induced EMF E is represented as E is equal to minus n phi dt. Now we know phi is equal to phi m sin omega t, so we will put ddt of phi m sin omega t. So we will get minus n phi m omega cos omega t. Now I have there is minus cos omega t, so I will convert it to equivalent sign. So that time it will be n phi m omega sin omega t minus pi by 2. Now let n phi omega is equal to Em, where Em is the maximum value of EMF induced. So now the equation is Em sin omega t minus pi by 2. The RMS value of Em is equal to Em by root 2. So now Em is equal to n phi omega, and where omega is equal to twice pi f. So now n phi m twice pi f by root 2. So this is equal to 4.44 phi m f into n. So this one is the EMF equation of transformer. So this is, remember, this is very, very important for the exam also. So EMF induced in the primary winding of N1 turn, that time it is represented by E1 is equal to 4.44 phi m f N1. Similarly, EMF induced in the secondary winding of N2 turn is expressed as E2 is equal to 4.44 pi m f N2. So if I write E1 by E2 is equal to, everything will be cancelled except N1 by N2. So E1 by E2 is equal to N1 by N2. So this is your one of the answer of this one question, question number 2. You know that EMF induced in the primary winding and the supply voltage V1 is almost equal. So in practical transformer, there is very small difference between E1 and V1 and E2 and V2. So we can write E1 by E2 is equal to V1 by V2 is equal to N1 by N2. E1 by E2 is equal to V1 by V2 is equal to N1 by N2. Now think that if the value of E1 is greater than E2, that means it is voltage is reducing, so step down. So if V2 is greater than V1, that means it is step up transformer. And V2 is less than V1, then it is step down transformer. So transformer, what we have seen, the step up transformer, step down transformer, based on our application, we design it, we connect the primary, the same winding can be used as a primary or secondary. Thank you for watching. For more videos, please like, subscribe and share. Thank you very much.